Hello students, welcome back. Previously we went through all the theoretical aspects of section 1. We went through the exponent rules, reviewed rather, not going through. And then we went through the definitions of the exponential functions and the properties of exponential functions. The graphs, typical case when the base is greater than 1. Please remember these graphs. Toward negative infinity, we have 0. Toward positive infinity here, going to positive infinity, and all going through the y-intercept of 1, strictly increasing this basic shape, please remember. This one is not even half as important. I'll say about 90% previously, this one is less than 10%. But still, there's a connection between one and the other, because whenever you have small base smaller than 1, you can take reciprocal and big bases bigger than 1, and then make appropriate comparison. What's the difference? We have the negative x power, so we have appropriate symmetry. So as for these problems here, you can just do everything here and flip it at the very end by taking the reciprocal, and therefore this part, these kind of things do not really require separate methods. All those formulas are all about the standard case when a is greater than 1. And these are common properties. And speaking of a value, base greater than 1, here is one very, very important and typical example. When the base e is greater than 1, certainly, but it's an irrational number with no and then no repeating pattern, 2.718 something, then we have this kind of graph. Please remember the shape of the graph, and a nice property here. The slope at this intercept point, 0, 1, happens to be 1. And the slope concept here is going to be very, very important in calculus, but for now, it's just a preview of what's to come. Just a graphical understanding, nothing more than that. Okay, so much for a quick review, and let's go to example problems. First, some elementary example problems. How do you do this? Maybe you can stop the playback and try, and you can come back later. How does it work? Basically, what we want is to take the same base and compare the exponents. So how does it work? 81 is 9 times 9, and 9 is 3 squared. So 81 is 3 to the 4th power. It's in denominator, so it's negative 4th power. So in short, we get this equation here. Same base, so we can simply compare the exponents, the powers. 2x minus 1 is equal to negative 4, and from this point on, it's easy. Once you get your solution, make sure you just plug it back into the original equation and see if it works. For this kind of simple exponential equation problem, it's going to be okay, but for some more complicated problems with some logarithms and stuff, things may not really work that easily, so checking for a possible extraneous solution will be necessary. How about the next problem here? Again, try to keep the same base. Did everybody try? Okay, I assume everybody did after stopping the playback. Let's go ahead. This 4 can be written as 2 squared. So this thing here, the right hand side, can be written as 2 squared to the y plus 3 power. And if you use the exponent rule, especially this one here, you can multiply the power and if you multiply out, what do you get? 2 to the 2y plus 6 power. That's the right hand side. So if you keep this one equal to the left hand side, you're going to get the equation you want. See, manipulate the right-hand side and compare. Same base, so you can compare the exponents only. Y equals 2y plus 6. That's an easy equation to solve. We get y equals -6. Once you get a solution, make sure you plug it back to the original equation and check. In this case, yes, it checks out. I use all those symbolic expressions, but punching into calculator is just fine. Okay, so much for really elementary problems. And then let's go over to a little bit higher level. Graphs of exponential functions and plot the graph. Okay, all right. We have plenty of time, so let's do some graphical exploration with graphing calculator. So let me stop the playback here and prepare this Desmos graphing calculator. Okay, I have it here. Okay, all right. This one here, and the graph looks like this. We have an intercept here, y-intercept, looks like -1, and x-intercept here, 1, and it's a little bit unclear here whether we have an x-intercept or not. Looks like it's just an asymptote, horizontal asymptote. And here, of course, no horizontal asymptote, it's just blowing up to infinity, apparently. So I expect -1 here, +1 here, and probably nothing here. The y-intercept is the easiest, so let's go ahead and find out. Plug in x equal to 0, we get 0 times e to the 0 power minus e to the 0 power. And what is it? 0 times e to the 0 power is, of course, 0. And e to the 0 power is anything to 0 power is 1. So we have -1. So y-intercept is -1. Let's go back to the graph again. Yes, -1. Good. How about the x-intercept? Looks like +1. Okay. That is x e to the x power minus e to the x power is equal to 0 because you want y equal to 0. See? Y value is equal to 0. And then we have to solve this equation. Oh my! Solving this transcendental equation, that looks really hard, but no, don't be intimidated. Whenever you have 0 in the right-hand side, just factor it. A times b is 0, then one of them has to be 0, you see? When this right-hand side is not equal to 0, then flip it over, take the like terms together, whatever, and keep the right-hand side equal to 0, and then factor it. Here, it's already 0, so I can factor the left-hand side, and I can factor common factor e to the x out, and what's left is x minus 1. Are you with me here? Therefore, the first factor is equal to 0, or second factor is equal to 0. But the first factor, e to the x equal to 0, that never happens. Where's the graph of the exponential function? Nope, not here. Here. Looks like this. It never hits 0, it's just horizontal asymptote. Keep multiplying or dividing by a positive real number, you're never gonna get 0 or negative. So that never happens. So x is equal to, I'm getting the solution x equals to 1, which is of course precisely what we expected right here. So when you solve a transcendental equation, don't panic. Keep the right-hand side equal to 0 and factor it. Here's the solution. Graph. Okay. And then intercept. Y-intercept, plugging 0. X-intercept, set the function equal to 0, and so for x. How about the next problem here? Well, we plenty of time, so let's go back to the Desmos graphing calculator. And negative x squared, nope, squared e to the, sorry, what did I click? E to the x power, no, minus x power plus 2x e to the negative x power. Okay, that's the graph. Did I copy everything correctly? And here's the graph. Runs through the origin. So y-intercept is 0, x-intercept also 0 here, and another x-intercept apparently at x equals to 2, and no more there. To the right, it looks like we have horizontal asymptote forming there, so no more coming. So 0, 2, okay, that's what we expect. Okay, how about the y-intercept? That's easier. G of 0. Plug in 0, so negative 0 squared e to the negative 0 power. That's of course 0. 2 times 0 times... Oh, why am I writing everything here? This is 0, that's 0, so it's clearly 0. Okay, alright. Y-intercept is 0. How about the x-intercept? And that is negative x squared e to the negative x power plus 2x e to the negative x power is equal to 0, and I have to solve for x. Again, the first step of transcendental equation is not panicking. Don't panic. And the next step is set the right hand side equal to 0 and factor it. It's already 0, so factor it. If you factor, then from that point on it's easy. Okay, let's take the GCF out. Everybody, please note that exponential is common everywhere. And then also x is common everywhere. And then what's left here is minus x, and from here 2. Are you with me here? X squared, x. X is common, take it out. Exponential is common, take it out. What's left is negative x plus 2. So, exponential is 0, which is impossible. The second factor, x is equal to 0. Alright, there goes 1. Negative x plus 2 is equal to 0, but let's just solve it right away. X equal to 2 like that. And this one is not going to be possible. Exponential is never 0, so cross it out. We have those two, x equal to 0 or x equals to 2. Let's go back to that Desmos graphing calculator. That's what I got here and there. So if you graph it beforehand, and if you know the answer a priori, then the solution is easier. Here's a graph given by Mathematica. Okay, alright. And intercepts are like this. Plugging x equal to 0, we got the y-intercept. And the setting the function equal to 0, factor it, you're going to get x equal to 0 and x equal to 2. Exponential does not really do a thing. Okay, so much for section 1 of this notebook. See you again in section 2.